recording and start the talk. So
Okay.
welcome everyone. This is going to be about Haxe. And by the way, if you have questions or anything, you can just interrupt. We're not a lot of people anyway, so I think it's gonna be a better format than if I just talk for the entire 30-40 minutes. So here we go. So in short, it's an open source programming language, high level, garbage collected, strictly typed. So all of that together, that makes it pretty similar to C# or Java in terms of the syntax. And what makes it really special is that it's cross-compiled, and we're going to see what that means later. And it has AST. So AST is the abstract syntax tree, and you can do metaprogramming on that tree, and that's going to be at the end of the talk. But those 2 points are really what sets Haxe apart from anything else that I've seen. So quick history: was developed by this guy called Nicolas Canas. So it's not a new language. It started in 2005, and so him at the time he was developing browser games. So the client was coded in Flash. Well, the language for Flash is ActionScript. Probably had a JavaScript front end for the social features of the games, and there was a backend, so servers and stuff. And using Haxe, he was able to merge all of these different tech stacks and languages into a single language. And at the time, he co-founded a game studio called Motion Twin. And although he's no longer part of Motion Twin, but recently they had a really good success with a game they released called Dead Cells, and that game sold, I think, over 2.5 million copies. You can see a bit of the gameplay at the bottom there. Some more games that use it. So top left, you have Northgard. That's a real-time strategy game developed by another studio that Nicolas founded. And they're using the exact same engine that was used for Dead Cells. Top right, you have Spellbreak, pretty recent release. That one's that one's a battle royale, 3D game. That one actually runs on the Unreal Engine, so it uses Haxe, not for everything. It uses Haxe specifically just as a scripting language, because Unreal, it gives you two options basically. It gives you either you do everything in C++, or you can do some things you can do using a visual programming language, but you really don't have anything in between. So this studio, they're using Haxe as something in between, from one extreme, C++, and the complete other extreme, which is a visual programming language. Then you have at the bottom you have Dicey Dungeons and Papers, Please. So those are more indie releases, and they're actually both built on the same engine called OpenFL, and we'll see what OpenFL is in the next slide. So one of the niches that Haxe has occupied is for game development in Flash, and this is because you can basically Flash was dying for a very long time, and as a platform, so lots of people they didn't know how they were going to keep releasing their game, distributing their game and stuff, or how they would continue working with familiar tooling. So Haxe essentially took all the tools and the tech for Flash and poured it over to itself. So for example, so here I divided the slide in two. So the top row, you have the first element is the language. So Flash uses ActionScript, and we can see there's the equivalent of Haxe, which it's a lot like ActionScript. There's actually been tools to automate, automatically port your ActionScript code base to Haxe. Next in the middle, we see the platform. So Flash, but it's not only a platform. It includes It includes a lot of like graphics API, sound API, input API. So like a lot of stuff you need to build a game. And here, and so the Haxe equivalent of that is OpenFL, which stands for, I think, Open Flash Layer. So they literally ported like the Haxe API, they ported over to the Flash API ported over to Haxe, and they made it available on all of these other platforms. So like Windows, mobile, web, all that stuff, no problem. And finally, you have a game engine that's built on top of the Flash stuff. So for example, there's many, but the one that like what personally got me into Haxe is I was using this game engine called Flixel. That's the logo like on the top right. And it got ported like almost 1-to-1 with a whole bunch of like improvements to Haxe Flixel. That's literally the name. And so yeah, that's like one example of what how Haxe can be used. So good so far?
Yep.
All right. So now I'll give you like a quick rundown of Haxe. These are not all the features. And basically at the end, like if you're curious if Haxe supports some feature, just like pop in chat and we can talk about it. But these are the ones that like in my opinion are the most like unique or useful. So I'll dive right into it. First feature is first class functions. And like in my view, what this means is that you can treat a function like almost exactly the same as you would treat any object. So here you can see like the context of this code sample is you're making HTTP request. So you're basically like querying a web page. So here you create your HTTP object. Next, you basically HTTP.onData. That's going to be a callback. And you see how you assign it a function like as if you created a new object. So you don't even call the function because you don't need to. But it takes in a string and it does something to the string. So this kind of like first class functions, it's really good for when you want to support like callbacks and like event driven stuff. Here's another feature. It's called conditional compilation. So but essentially it's like, I think of it as compile time if statements. So you can decide to include or exclude certain code at compile time. So this so this is a bit of a contrived example, but usually you would use this for compiling to different platforms. So for example, if you wanted to compile to Windows, you would put your Windows code, like you would do like hashtag if Windows, and Windows would be a variable that's defined in your compiler settings. So the compiler knows about it like at compile time. So you would put it like in between these tags, you would put your Windows code, then you would put like hashtag else if Linux, then you would put your Linux specific code and so on. Does this make sense?
Yes.
All right. Next one is DCE. So DCE stands for dead code elimination. But first I'll go over the reflection API. So reflection is like, it's kind of when you're not sure, like in the wild, how you would use it is when you're not sure about the type of your object, but you want to like introspect that object and either call some methods inside of it or like access some fields, but you're basically working outside of the type system where the compiler like it can't check what you're doing and it can't assume anything about what you're doing. So it's a bit of a Wild West thing, but occasionally it's useful. And so in this example, if you go into the main function, so here we create our my class, which has only one function, print name. And for whatever reason, instead of calling it like myObject.printName, we're going to use the reflection API. So first we obtain the function by name. So so now we have our handle to the function, and next we use reflect. That's literally like built into the language. Reflect.call method. So we give it the object, we give it the function handle, and we see print name doesn't take any parameters, so we don't give it anything. We give it an empty array. So that's gonna call our method. But if we only did that, chances are like the program wouldn't even work, because the compiler, when it looks at this entire file, from the compiler's point of view, the function print name is never actually called. So by default, Haxe is going to remove this print name from the output, because like as far as it can tell, it's completely useless. So it's going to use DCE, dead code elimination, to remove print name. Now, in our case, we know that we're actually calling print name. So what we're going to do is we're going to add a metadata tag. So if you look at the line 3, you see the the @ symbol with keep. So that's going to tell the compiler to not perform dead code elimination on this function. Is this good?
Yep.
All right. Quick slide on static and generics. So static works the exact same way that it works in Java and all those other languages. Generics, I think so as well. Maybe the one detail you have here, for example, you see class item. So you can constrain the generic parameter to be of a certain type. So here I constrained it to gear. I think that's like the only really special thing about generics in Haxe. Otherwise, it behaves like the exact same way you would expect. Abstract types, honestly, I don't know how this works in other languages. I've only seen this in Haxe. But the idea is you want to define a class with custom behavior while still using a basic type for storage. So a basic type like int or string or bool. So it's a pretty cool use case. For example, here we're essentially validating email addresses, but we're not using like any another class to do it. We're still keeping everything as a string. So you can see abstract email address, string to string. So basically everything before the to keyword, that's going to be kind of, it tells you like what your constructor would look like for this abstract type. So you have inline public function new. New is the constructor. So it's going to try to match the regex on the string that is provided, and if it doesn't match the regex for like typical email format, it's going to throw an exception. Okay, it actually does another thing. It kind of normalizes the email address, so it puts the entire string to lowercase. So it's a nice little pattern. Like in practice, it doesn't come up often, but when it does, it's really neat to have this kind of stuff. Another example is for working with colors. Color is often stored in a 32-bit integer. And this is because you can neatly separate like all your 4 color channels into 8 bits. So it saves a lot on storage, but it becomes really painful to work with. If you want to access, like, you have your color stored in an integer. Now you want to see what's the red value or the green value. Now all of a sudden you have to do like bit mask operations and like bit operations on it, and becomes like a headache. But you can wrap it around into basically an integer, an abstract integer color, and you can have all of this done for you. in the background. So you'll treat it as if it has all these separate fields when it's actually just one integer. Right. Okay, so let's look at from this function from ARGBI. So you're passing it all of your 4 channels as integers. And what it does is it's going to construct your color. So that's going to be the constructor. We'll go back to the constructor later. But it's going to basically merge all of these, merge into a single 32-bit integer, pass that to our constructor, which is probably lower. Okay, so function new, what does it do? This is a parameter. So it basically sets itself, and itself is just an integer, sets itself to this parameter. So is this okay so far?
Yep.
All right. So now we finally get to basically the benefits of all of this is, for example, if I want to get the red channel as an integer, now I can define a function for this, which is going to take, our value, and it's going to do the appropriate bit operation. So it's going to shift, and then it's going to mask, whatever, it's not really important. Same thing for setting it, etc., etc. So in the end, you can, here's an example of getting the red channel, for example. So you can really treat like your color, you treat it as like a complex class, but all of it is really still being stored inside a simple type. I'll skip this slide. If anyone has questions later, I'll come back to it, but it's really not that interesting. All right, so finally we get to cross-compilation. What it means is that when you compile your code in Haxe, it won't compile to like a binary right away. What it's going to do is it's going to compile to another language first, and then it's going to use the tools of that language, and its ecosystem to produce like the final result. So Haxe, all it has to do is, well, it needs to like re-implement its standard library inside of that language. This is, it's not, as a regular Haxe developer, you don't really think about that. That's already done for you. Also the garbage collector. So depending on your target language, Haxe will provide one or not. So yeah, let's look at an example. So this is an actual project, OGMO 3 level editor, just like a 2D editor for games. So this one's written in, it's written in Haxe, but it's targeting JavaScript and more specifically Node.js and Electron. So Electron is it's like an application framework, and actually Discord is using Electron and stuff like Slack. So it's for making like desktop applications that run on top of Node.js. So if we look at the directory structure of OGMO, it's pretty familiar for like Node.js developers. So you have some familiar folders like Node modules. You're gonna have your package.json, stuff like that. So your source code, in this case, the source code is all in the source folder. It's all in Haxe. And so the Haxe stuff gets converted to JavaScript, and that's going to be in your bin, build, and dist folders. So if we look at a little like extract, let's say we focus on the first function activated. So we can see it's a fairly simple class, a grid pencil tool. It extends another class. It's inside of a package, so I think Java also has packages, right?
Yes.
Yeah, it works like it probably works the exact same way. So you have a function, a really simple one, just setting a member variable to false. So let's see what this looks like in JavaScript. And it looks fairly similar. It's like a really, honestly, pretty much a one-to-one translation. That's because both are like high-level languages with pretty much like the same, like very similar concepts. So here we have our like variable, which is the package stuff and the class name. Next, what do we have? This is the prototype. This is like old JavaScript class syntax. So here you see this is our activated function, and this is like the one line, literally like the exact same line that we had before. So yeah, basically the Haxe compiler is gonna translate like all the Haxe code to JavaScript code, and so yeah, that's really it. And then it's gonna use like JavaScript and Node.js tools like, I don't know, like Webpack, things like that to make it run. So here's another example. This one's going to be like an example of cross-compilation to C++. So here's the Haxe code, and this is a bit interesting because this class has different behavior if you're compiling for native. And what I mean by native is like not web. Actually, let me flip the logic here. So basically it's gonna have like specific behavior for web, but for everything else it's gonna have another behavior. So here you can see the compile time compilation. Sorry, what was this? A conditional compilation. So here's the check if it's not JavaScript, not HTML5, and if it's not display. Display is a special one. That one is for auto completion. So basically, if we're in an auto completion engine right now, we're going to want to display like the regular behavior, which is, we have a class which extends something, and it has two like pretty simple functions. Now, if we're on web, basically web already has an implementation of a shader. So we're gonna type that, which basically means we're gonna rename, like we're gonna use the left-hand side as an alias for the right-hand side. And here's what this looks like in C++. This is not designed to be like human readable, but we can look at some stuff.
Looks like Kaiju's code to me.
No, this is like way worse. But yeah, definitely not designed to be human readable, and it has a lot more, like, this is not one-to-one. This is lots of extra bookkeeping. You can see, for example, the stack frame. So because, like, actually I'm not even sure what this does. It has a lot of like extra stuff like line. I think this is like to say that in the Haxe source code we're on line 16 to generate like exception messages. Like if the code crashes here, it's going to be able to tell you like, oh, you crashed on line 16 of your Haxe source code. But yeah, and even the types, like for example, is not equal, like in JavaScript, in the JavaScript output, we were able to use the equals operator directly. But here, we have to, it's a bit more complicated, so we can't even use like the equals operator directly. We have to wrap it in special stuff. So yeah, that's all I'm gonna say about the C++ code. It's more complicated, but it works. And the final topic of this talk is macros or metaprogramming. So how it's different inside of Haxe versus a lot of other languages like C++ is that in C++, for example, you're going to be able to do metaprogramming at the source, kind of like the source code layer, which means you're going to practically like replace some text by other text. And that's very limiting because, you know, like the replacement rules and everything, they don't necessarily have a lot of context, and they're not, you can't like define very complicated rules with that. But with Haxe, you have your metaprogramming at the abstract syntax tree layer, and we'll see what that tree looks like in a sec. But it's basically, you have all the context. You can really like do like surgical removals and additions of code. So let's look at an abstract syntax tree. So here's an expression at the top, 2 times 7 plus 3, which is just like, pretend this is just like a line of source code. Most compilers out there are going to generate a tree out of it. So you can see on the right side of the image, it breaks down into like an expression, and here the expression is an operator, and it has a left hand term, right hand term, and it breaks down like so on. So doing metaprogramming on this level, it means you can, all of these nodes, you can add, modify or remove any of them. And this isn't only for statements. So like a class declaration is also going to be parsed into a tree. A function declaration, so like its name, the name and type of each of its arguments as well. So like, just like looking beyond like simple statements, it means you can modify like all of this stuff as you see fit. So here's an example. This is an actual library called HXBIT. So it's a serialization library. So what it means is, you know, for some objects that exist at runtime, you can make it like spit out a representation that you can save on disk or send over the network or something like that. And what's special about it is it's using Haxe macros to provide a really convenient API to the user. So here you can see the fields that you want included in the serialized representation. You tag them. So this is the macro syntax. It's similar to the DCE stuff we saw earlier, like the @keep thing. It's basically just passing messages to the compiler. So here our message is, you know, serialize these specific fields. And then this library is going to, like, during compilation, so this is like your compilation process. So the library also is going to be called and run here in the macro processor. It's going to identify all of these fields that you flagged, and it's going to like output a whole bunch of other code that's going to make the serialization possible. And that's going to do like the entire process. So as a user, all you're going to do is, once you've tagged your fields, you know, you create your class user, right? So assuming you have an existing user, you're basically going to get the bytes from it. And same thing for creating a new user from those bytes. So here we have a serializer. So that's on the other end, unserialized. So you pass it the bytes, you pass it the class, and the library knows what to do with it, and it's going to return a user object. Is this good?
Yep.
All right. Another really like common use case for macros is compile time code. So you can basically write any code you want, and it's going to compile. It's going to run at compile time instead of runtime. So here, for example, if you wanted to include your Git hash and reference it inside of your build, so how you would do this is you declare like this function a macro. So so now Haxe knows this is supposed to run at compile time. And what does this function return? It returns an expression of type string. So this is like the equivalent of a string literal. A string literal, basically, anything, this kind of string that's defined in between quotes. So it's basically going to skip all of it if it's in the display context. So display, again, that's for auto-completion, the autocomplete engine. We don't want to run this every time, someone's trying to get auto-completion on this field. So what we're going to do is we're going to spawn a new process, and this is actually, it's going to do like a system call. Well, not exactly a system call, but it'll forward this to, like the console on the system. So it's going to run git and these parameters to git. I don't know git that well, but I assume this is going to give you the commit hash, like the commit ID for your branch. It's going to check the exit code on it. If it ran successfully, it's going to get all the output, which in this case should just be the hash you're looking for. Wait a sec. Oh, okay. If your exit code is not 0, that means there was an error. So it's going to grab the contents of the error. It's position. That's just like an extra feature, basically, to say which line your error occurred, and you're going to throw an error. Right. But if the process did not throw an error, then you're basically gonna read the console output, and finally you're gonna return this, and the $V it's basically gonna tell it to treat this as a value instead of like to grab the string expression inside instead of treating it as a value. And that's it. We're pretty much done. So how we're going to use it is we'll store it as a static variable, commit hash. Okay, so this is something I didn't go over, but it's like getter setter, like in Java, getter setter syntax. So this is I think the getter. So default behavior, which means just return whatever the variable is, and never for setter. That would mean that you can't modify the variable at all. And here we give it its initial value, which is the commit hash. And inside your program, you would use it like this, basically trace. Well, you could do either. You could either reference commit hash, or you could. No, sorry. Yeah, so inside of your final program, you would reference commit hash. But if for whatever reason you want to get the commit hash like at runtime, you can also do it. So it's not only like this function can also run at runtime. So it's not only limited to compile time. Any questions about this slide?
Nope.
All right. Here's another compile time little feature. So for example, I don't know, you're working on a program and it has some configuration stored as JSON files. So it would be pretty neat, for example, if you could validate them as well at compile time. So it's a bit, it's a similar pattern. So macro function, validate JSON, and it's going to use, so like sys.filesystem is going to use all of these file system functions, which are part of the Haxe standard library. And it's going, so you're going to read the file contents. You're going to, so Haxe provides JSON like parser and reader in the standard library. So you're just going to use it to try and parse it. If it fails, then, you know, we know there's an error. And we're going to do something like very similar to the previous slide. And so in practice, you're going to, here's our main function. In practice, we're going to tell it, okay, here's our paths for the JSON files we use, and validate these at compile time. Well, that's pretty much it. I don't know. I could end here, or I could do these two other slides, but it's up to you guys.
It's up to you as well. I don't mind.
All right. This is a bit of a more advanced use case. So this is in the context of you're making a game and it has multiplayer. So you have to like basically replicate state from like client to server, like update, you know, the state of the game that's on the server. You want to push that to the client. So like one really neat way to do this is, you know, if you could, similar to the serialization library that we saw before, if you could just like tag the fields that you want to be kept updated, if you could just tag them with something, and like under the hood, you know, like some library will take care of it. So to make this kind of interface, you would use metaprogramming. So here's an example of what we want as a final product. Have your base class, so no metaprogramming here. Is just class player, 2 fields, and and 1 function. Here's the kind of the version of this class that's going to run on the server. So this one's going to have all the metaprogramming. So it has an build function, and builder.buildController. We'll see the source code on the next slide. But it tells the compiler to run like this macro function on this class at compile time. And what we're gonna do is, so we know we wanna like replicate the position of the player. So we're gonna tag both of these fields with like this label, which it could be anything. It depends on what code you have inside of your build function. Okay, and we also want, for example, when the player explodes on the server, we want this to be broadcasted to all the clients as well. So we'll also tag, for example, the function. Here's the version of the player that's going to be on the client. That's not very important, actually. I think you can just focus on these two. And something to notice is, you know, like in any object-oriented language, if you try to like redeclare your member variables in a subclass, you're gonna get a compile time error, because these fields are already declared inside of player. But for our API to make sense, we actually have to be able to do that. So one of the neat tricks that build controller is going to have to do is going to have to check if this variable is already declared in the superclass, and if it is, it's actually going to erase this whole expression. It's going to erase it from this class so that we don't get like a compile time error. But it's still going to record that we want replication on it. Is this okay for this line?
So what does net do? I didn't really understand. It broadcasts the changes to the client?
Yeah, so it's kind of, we're not actually going to go into the details of how it does it, but for now we're kind of looking at it from a user's perspective.
Okay.
So yeah, for example, I'm a developer, I'm making this game, and so I want to be able to have this kind of neat interface where anything that I want to be synchronized on other computers, I just like extend my class, I tag the fields and the functions that I want to synchronize, and that's it. From my point of view, like I'm done, right? And something else like takes care of.
Okay. And does it like wrap it in like a public subscriber or do you know?
Sorry, you cut off for like a second.
I said, does it wrap it into like a publisher subscriber or something to make it happen?
Internally,
It's okay. I was just curious if.
I'm not sure, but like to be clear, this library doesn't actually exist. This is kind of like if you wanted to design it that way, and if you wanted it to, to have this feature of, I just tag whatever I want, like we saw in the HXBIT library.
Okay, that's fine.
So now this is the implementation of our build controller. So this build controller is going to have access to the entire like abstract syntax tree of the class. And it gets, basically this is kind of the root of our tree, context.get build fields. So what we're going to do is we're going to iterate over the fields. So imagine we're iterating over the variables and over the functions. Here, for example, we detect that we're iterating over the constructor right now. And let's say we wanted to treat the constructor in a special manner. So we're going to do something special for it, whatever. Right. So now we have our field, which is either a variable or a function, and we're going to iterate over the meta, like the meta tags. So this is everything that starts with an at. So for example, our at net. Here we determine if this specific field has a net tag, or for example, a fast net tag. If we didn't find either, then right. So basically the ret.push field, ret is just an array of fields, and this is our new abstract syntax tree that we're going to return at the very end of the function. So we're kind of getting the old abstract syntax tree, doing whatever we want with it, and return a new one. So super powerful. You can, like, as we'll see, right. So if the field, the variable or function doesn't have any of our net or fastnet tags, then we don't do anything to it. Next, we determine which kind of field it is. So if it's a variable or a function, and this kind of syntax, it's so it's a switch, but it's a pattern matching switch. So what it means is it tries to see if it's basically, for every case, it's going to try to see if this thing matches this type, and if it does, it's also going to like populate your T and E with whatever the constructor of this type is. Honestly, I don't really use pattern matching often. Like, this is the best that can explain it. I don't know, maybe Tatum can explain it better. I don't know if it's ambiguous or not. All right, I'll assume it's all good. Right, so if we detect that it's a variable, then for example, us as the networking library, we want to keep track of the variables we want to replicate. So we're going to just like push it to, this is just an array. So we'll store it in an array for now. What else are we going to do? We're going to determine what's the superclass. And this is for the little hack that I was talking about before, because you can't like redeclare your variable. If you do, that's going to be a compiler error. So we want to erase, if we detect that it's the case, we want to erase it from the child type. So basically this is like a big condition just to detect all of that. And if it's all good, we include in the new abstract syntax tree. If it's going to be a compiler error, we don't. So that's all we do for our variables. For our functions, it's very much the same. When we get all of its parameters, and we look at the types, push, where the names. Okay, I'm a bit blanking on this one, so I'll skip it. Okay, and this is going even further in the metaprogramming. What we're gonna do is we're gonna find our constructor again. We're gonna pattern match it so we can treat it as a function. And then we're gonna add like literal lines of code to it. So I'm trying to follow the logic. Oh, right. So for example, like ignore like all of these lines. Focus maybe focus on this line, for example. So we're literally adding expression nested. That's kind of the node in the abstract syntax tree that represents the contents of our constructor. So we're pushing it. Macro means like treat this like literally as a line of code. So we're gonna add this to the constructor's like source code. And the logic, for example, is when this object is created, we want it to be automatically announced to all of the clients because it's a replicated object. And so, like, why we're putting this in a build inside of build controller is so that the user doesn't have to repeat all of these lines of code for each class that they declare. So like in player controller, for example, we don't even, we're just using we're only using the default constructor. But thanks to build controller, the default constructor is going to have all of these lines of code that manage the network side. I think that's it for this slide. And that's it for the presentation.
Nice, thanks. I have questions.
Yep.
Does Haxe not support like method overloading or function overloading?
It does.
It does, okay. I was wondering because that library you were showing, or that class where you were doing RBG conversions, there was definitions for each type, like integers, floats being supplied.
Mm-hmm. This one?
Yeah. What is it? Yeah. It was like from one of those from I and from F. Yeah. So if you see from AGB,
this one,
ARGBI, yeah, and then you have from ARGBF. Why is that needed? Oh, is it because they have different? Okay.
I think it's just Wait, let me think. GBI. Wait, does it have? Wait, so you're asking about function overloading?
Yeah, like couldn't you not just name it the same way, but just pass different parameter signatures?
Oh, okay.
And
No, I
like,
think Haxe specifically does not support that, and it's a bit of a pain.
okay,
I think, like, I'd have to check, honestly. I know for constructors, you definitely cannot do that.
okay,
For regular methods, I don't know.
okay.
Yeah, good question, but I don't know.
Sounds good.
Any other questions?
Hi, I have a question.
Yep. What's up?
I'm just is this language based off of Java? Because I'm just noticing like syntax wise, it's really similar to Java.
It's super similar to Java. Yeah, I think it follows a specific convention called ECMA script. So like
Okay.
TypeScript, C#, maybe Java to an extent. Like they
Okay.
all look alike.
Okay. But like, sorry, I came to the presentation a bit late. So is this more like a web specific language, or is this just like a general purpose kind of dynamic? Why is it dynamic? No, it's actually a static language. But like, is this just like a general purpose kind of programming language, or is it like specific to one?
Yeah, it's super general purpose. It can so like the concept of the language is you write it in Haxe,
Okay.
and then the Haxe compiler spits out the same code, but like translated to a number of languages you can choose from. So it can like spit it out in JavaScript, spit it out in C++.
Okay.
And then let's say if you're using C++, it'll use the C++ tools to generate the binary from the generated code. So it covers like a lot of niches. It's mostly used for game dev, but you can have so for example, this is a program that runs on top of Node.js using Electron.
Okay.
So like this is kind of web development.
Does it like? Can you I guess it's kind of like a fancy transpiler. Like, could you write code and like eventually compile it into like binary for like WebAssembly, or is it more higher level stuff?
No, you could. I think like transpiling is. I'm pretty sure it's kind of the same thing as cross-compiling. They might be synonyms. So yeah, it's probably like along the lines of what you're thinking.
Okay, cool. Yeah. I was just curious because like I'm working on a project now, and we're using mscriptin, which is like a library for C++ where you can transpile C++ into WebAssembly and also like JavaScript.
Right.
But like I wasn't aware that like that this even existed.
Have you looked into Kotlin? Because that is officially supported.
Kotlin, no, but I thought Kotlin was more for Java projects.
No, it is actually multi-platform now.
Oh, I see.
If you came to my talk, you would have known this.
Well, I didn't know you had a talk. Maybe if you told me about your talk.
We have regular updates in the server events channel.
I know I'm not in the server events channel,
you are. You just, I guess you muted it.
Yeah, probably.
Shame on you.
I'm a busy person.
Okay, here's the last curveball for you. So you've been shilling Haxe for a while now.
Yes.
And you make a case for it, especially for the game dev community. It's familiar like JavaScript, but it supports, a lot of platforms. So for cross-platform game development, that seems really neat. So let me ask you this. Why, in your opinion, has it not gotten more traction?
I think because it covers a very large area. That's one. Because if you look at it, so for example, if you're maintaining an engine, or like let's say you're maintaining an engine. So now you have to think about how it works on Windows, how it works on Linux, how it works on all of these things. But because it's cross-compiled, you also have to think about how it builds on all of these platforms. So now you have to know how the Android SDK, how it's all like managed under the hood, how like Gradle works.
Right.
You know, for iOS, I'm not even gonna like honestly, I don't know anything. I just know it's a bit of a dumpster fire.
Yeah.
Um,
So what made Unity more appealing then, and why is it taking off more?
Unity, it's just there's no way Haxe can compete with Unity. For one, Haxe is driven. It's really mostly open source and like not.
Oh, Haxe is closed source?
No, it's open source.
This is like more of a cross compiler than a game engine. I feel like Unity is more like it's like a cross platform game engine. So it comes with like, you know, an editor tool. Like, yeah, I guess like there's like a layer of Unity that might act like this, but I feel like it's just like you're comparing apples to oranges. I don't know. Maybe
I guess like Andrew's asking why there's no why there's no like game engine built on top of Haxe that is as popular as Unity.
Oh, okay. You just gave me a new company idea.
What is it? Is it that?
I'm gonna make a new game engine, guys, built off of Haxe.
Oh God! Use Colin. Okay.
Yeah,
so
actually,
it's just,
it's pretty recent, but this guy, so Nikara, he just released something of an editor like Unity, but built on top of Haxe, built on top of the game engine that powers Dead Cells and Northgard and his other games.
Okay.
Actually, Dead Cells is not his game. I just keep calling it his game because he co-founded the company like 10 years ago. Then he left. But yeah, it's just I don't know. It's for sure it's not as widely adopted. I don't know. It's just also like the ecosystem. So like the libraries, the game engines. It's a bit of a chicken egg problem. Like the build platforms, all of that stuff. There's not that many people working on it, so there's not that many users. So there's gonna be like edge cases.
Okay.
Like leaky abstractions, all of that, and I think that puts some people off, like because it's a bit more risky.
Okay. So just general maturity and.
Yeah, but also I'd say it's pretty mature now. Like it's pretty old, like as far as languages go.
Right.
It's just I think it tries to cover like because it's cross compiling, so now it suffers from the concerns of the languages that it compiles to, their build platforms and everything. And so getting all of that into one package, it should definitely be like, these are all like volunteers, but if there was, well, actually, like the founder Nikara Kanas does this for a living, but overall I'd say like, it's kind of volunteer labor.
I see. Okay.
And maybe even like, because I remember back in the days, nobody was really talking about like transpilers and cross compilers, as far as I know. So I think like maybe it was, now that it's more of a trend with like Kotlin and TypeScript, there's less of a niche for Haxe. It's also possible.
I see.
Like someone took its lunch, basically.
Nice.
Any other questions?
Yeah.
Invest into Haxe stocks.
If you want to go bankrupt.
All right.